There's a hospital record from 1936 that basically breaks the most obvious thing you think you know about your own body. In it, a surgeon named Lewis and his colleague Pickering are testing nerve damage in patients, and they notice something that shouldn't be possible. Patients with severed sympathetic nerves in their hands submerge those hands in water and come out with perfectly smooth fingertips, not a single wrinkle. The skin still got wet, it still absorbed water just fine. But nothing happened. That detail got filed away, mostly ignored, for 75 years. Today, we're figuring out why that record matters, what your fingers are actually doing when they wrinkle, and why it took until 2011 for anyone to ask the question that was hiding in plain sight the whole time. For most of the 20th century, the wrinkling explanation was settled science. Textbook stuff. You submerge your hands, water soaks into the outer layer of your skin. The stratum corneum, the tissue swells unevenly, and the surface buckles, exactly like a piece of wet paper. Osmosis. Done. Move on. It is a deeply satisfying explanation. It feels mechanical, obvious, almost beneath further investigation. The problem is that Lewis and Pickering's 1936 finding makes it completely impossible. If wrinkling were purely mechanical, just swollen tissue buckling under water pressure, then the state of your sympathetic nervous system should be completely irrelevant. Water does not consult your nervous system before soaking into your skin. And yet, patients with nerve damage came out of the water smooth, every time. For the osmosis theory to survive this fact, you basically have to pretend the fact doesn't exist. Which, for most of the 20th century, is exactly what happened. Here's what most people assume when they think harder about it. Fine, nerves are involved, but it's probably still passive. Just blood vessels tightening slightly in response to water exposure. The skin losing volume, collapsing inward at weak points. An accidental byproduct of vascular housekeeping. Reasonable. Also wrong in a way that changes everything, because accidental processes produce random results. And wrinkle patterns are not random. Look at them closely, really closely, and they're organized. They follow ridges, they form channels. They look, under magnification, almost exactly like the grooves on a car tire, which is either the strangest coincidence in biology, or it's the whole point. In 2011, a neuroscientist at Newcastle University named Tom Smulders finally read the Lewis and Pickering paper and had the thought nobody had bothered to have for 75 years. What if this isn't a side effect? What if it's a feature? Smulders proposed that wrinkled fingers function as rain tires, and the analogy is almost too clean to be real. In Formula One, wet weather racing uses grooved tires. On a dry track, slick tires win, maximum rubber contact, maximum grip. But on a wet track, a slick tire, aquaplanes. A thin film of water gets trapped between the rubber and the road, and all that contact becomes useless. The grooves exist to channel water away, cutting escape routes so the rubber can reach the tarmac underneath. Your fingertip wrinkles do exactly this. When you press a wrinkled finger against a wet surface, water evacuates through the channels between the ridges. The ridgelines make actual contact. You can grip things. The mechanics work like this. When prolonged moisture is detected, the sympathetic nervous system tells the blood vessels in your fingertips to constrict. Less blood volume means the tissue shrinks slightly inward. But your skin is anchored at specific points, around sweat gland openings, connective tissue attachments, so it doesn't collapse uniformly. It folds in a structured, repeatable pattern. The channels form, deliberately. On a biological timer, about 5 minutes in. This is your nervous system running a grip enhancement program. Not an accident, a deployment. Here's where it gets strange enough to make you question everything you thought you knew about this. If wrinkled fingers are a grip tool for wet environments, your toes should show the same effect. And they do wrinkle. But the pattern is different. Finger wrinkles form channels optimized for manipulating small objects. The architecture of hands picking up wet stones, fish, roots, and tools. Toe wrinkles form a different structure, better suited for stable footing on uneven wet surfaces underfoot. Same system, different tuning, for different mechanical jobs. Evolution didn't stumble on one trick and paste it everywhere. It appears to have iterated the pattern twice for 2 different applications. And then, in 2014, a team published a study in PLOS, Hazeliu and colleagues, that found wrinkled fingers made no significant difference to wet object handling at all. Direct contradiction of the 2013 Caraclus result. Same basic question, opposite conclusion. So the science is not settled. The rain tire hypothesis is compelling, and the mechanism is real. But whether wrinkled fingers actually improve grip in measurable conditions is still being argued, which is slightly embarrassing given that you've been doing this your entire life, and biology still can't agree on what it's for. Which brings us to the most human part of this story. Why did Lewis and Pickering's 1936 observation sit untouched for 75 years? Why did the wrong osmosis explanation outlast multiple generations of biologists who could have questioned it? The answer is a quiet, institutional failure, and it's slightly maddening once you see it. Neurology and evolutionary biology are different worlds. They publish in different journals, attend different conferences, cite different literature, and historically, they do not go out of their way to read each other's work. The Lewis and Pickering paper lived in neurology. It was a clinical observation about nerve damage. The people who studied evolutionary adaptations for grip and locomotion were not sitting around reading clinical neurology reports from the 1930s. Tom Smulders, the Newcastle researcher who cracked this open in 2011, is actually a behavioral ecologist, someone who thinks about animal adaptation for a living. He read a neurology paper from 75 years prior and immediately thought, that sounds like a feature, not a bug. But he was only reading it because he'd gone looking specifically for this kind of anomaly. The osmosis theory, meanwhile, persisted in textbooks not because anyone rigorously tested and confirmed it, but because it was satisfying enough that nobody ran the experiment to challenge it. No funding body was offering grants to study why bath fingers get pruny. It looked like a finished question. This is how science actually fails. Not through fraud or conspiracy, through separate silos of knowledge that don't speak to each other, and through the quiet institutional gravity of the explanation. That was good enough. It took one person to cross a disciplinary fence and ask a slightly inconvenient question. Then it took two more research teams, one positive and one negative result, and now we're in a state where the mechanism is understood, but the function is still being debated. For a trait that fires up on your hands every time you do the dishes. Next time you pull your hands out of the bath and stare at those wrinkles, you are not looking at waterlogged skin. You are looking at ancient software executing on modern hardware, a program that predates modern humans by somewhere around 150 to 300 million years, shared with macaques and possibly other mammals that regularly navigate wet environments, running on the same sympathetic nervous system that handles your fight or flight response. Your body didn't bolt this on as an afterthought. It's wired deep, it runs on a timer, and it's tuned differently in your hands and feet for different mechanical purposes. That's not an accident, that's engineering. And the entire 20th century of biology looked at it, nodded at the first plausible explanation, and moved on. Because the bathtub pruny finger problem simply did not feel like a question worth pursuing. The broader truth, and it's a little uncomfortable, is that the most dangerous kind of wrong answer is the one that sounds so right that no one writes down the evidence against it. If you enjoy finding out that the things you've ignored your entire life are secretly running ancient biological programs, and that scientists occasionally take 75 years to notice, please like and subscribe.